Alright, so today we're going to be talking about geometric sequences and series. These first two pages are going to be all about sequences. A sequence in which the ratio between successive terms is constant is called a geometric sequence. The constant is referred to as the common ratio. And we denote this using the letter R. So with arithmetic sequences, we were adding or subtracting, and we called that the common difference, D. With geometric sequences, we are doing what? What are we doing? Dividing. Or not dividing, but multiplying. We are going to be multiplying. If it is dividing, then I still want you to multiply by a fraction. Does that make sense? Okay. So I'm going to skip a sentence and say, given a term of the sequence, to find the next term of the sequence, multiply by the given term by the common ratio. While the rate of change of arithmetic sequences is constant, the rate of change of geometric sequences can either increase or decrease. Now, the common ratio, our R. How do we find the R? I skipped that sentence. It's right here. To find the common ratio of a geometric sequence, you are going to divide any term following the first term by the preceding term. So I like to say you are going to divide the second term over the first term. You are going to do second over first. Here's question number 1 and question 2 on your quiz Monday. Determine the common ratio and find the next 3 terms of the geometric sequence. What do I do first here? Divide. What am I going to divide? I'm going to do my second term over my first term. So negative 2 divided by 8. What is negative 2 divided by 8? Negative 1 over 4. That is my common ratio. Thank you so much. Okay. And then what else does it ask me to do? The next 3 terms. So I just need to continue this 1, 2, 3. What am I going to do to find the next term? Multiply by negative 1/4. What is 1/2 times negative 1/4? Negative 1/8. Times negative 1/4. Multiply them. What is 8 times 4? 1 over 32. And then does anybody know what 1 over 32 times negative 1/4 is? Negative 1 over 128. Perfect. First question on your quiz. Are we okay? All right. Determine the common ratio and find the next 3 terms of this sequence. This one's a little bit different. We got letters in here. But what's happening from here to here? It's multiplying by 2. You could still divide your second over your first, and you would get that as well. So what's going to be my next term? 8w plus 24. And then 16w plus 48. And then perfect. Now, I just graded the front page of your quiz B's, and a lot of you did this and got points off. What is wrong with what I have for example B?
There's no common ratio.
You don't have the common ratio. Miss Alvarez, you said it's right here. How do I know that? What do you need to do? Label it. Okay, you need to have some sort of label. A lot of y'all did the plus 17 on the quiz, but you didn't identify that that was D. You just assumed that I assumed. Okay, so be careful about that. Everybody cool with that? That's 4 and 8 on your homework today. Okay? In section 10.2, you learn that arithmetic sequences can be defined both recursively and explicitly. This also applies to geometric sequences. Each term in a geometric sequence is found, again underline, multiplying the common ratio times the preceding term. Therefore, recursively, to find a of n, you're going to take your previous term and multiply it by your r. I do not personally care if you put r at the end. You could also do r times a of n minus 1. These are the exact same thing. This is the recursive formula. What else do you need for a recursive formula? The start and the domain. Do y'all agree with that? Okay. Next, the nth term of a geometric sequence with the first term a of 1 and a common ratio r is given by, this next one is our explicit formula. I already actually taught you the explicit formula. Does anybody remember what it is for geometric sequences? It is. It's going to have a power, but what do we start with? A of 1, r to the n minus 1. I gave y'all that like on page 4. For geometric, it's a of 1 times r to the n minus 1. And I always want that r in parentheses. So, for example 2, this is the exact same sequence we had above. What was our r here? Do y'all remember? Negative 1/4. So what is my explicit formula going to be here? A of n equals a of 1 is 8, negative 1/4 to the n minus 1. N minus 1 isn't, this is the explicit formula. Right? Sorry, I did the explicit formula first. Does that make sense?
Oh, I was thinking of a of n minus 1 being in recursive.
Okay, so I get what you're saying. That is when you have the a value with the n minus 1 as a subscript. This n minus 1 is an exponent. Does that make sense?
Oh, yeah.
So they're both going to have n minus 1 just in different spots. What about the recursive formula? How would I find the recursive formula here? What do we need for recursive? 3 things. What are the 3 things we need? The start, a of 1 is 8. What else do we need? What's happening each time? A of n minus 1 times negative 1/4. Put that in parentheses so it doesn't look like they're subtracting. And last but not least, what do we need? The domain. That is my recursive formula. Questions? Okay, that's the next 2 on your homework. Super quick, right? The 2 after that are, how do I find the 27th term of this geometric sequence? What do I know by looking at this sequence? What's a of 1? A of 1 equals 189. All right, somebody new I haven't heard from. What else do I know? I'm going to start cold calling y'all. What do I know? How did we get that? Can you explain your process?
Divided 151.2 by
I do my second term over my first term. And if I do 151.2 divided by 189, I get 0.8. And 0.8, do y'all agree, is 8 over 10? Which reduces to 4/5. Okay, somebody else I haven't heard from today. There's one more thing I know. N is 27. That make sense? I'm going to plug into my explicit formula everything I know. So I want to find A of 27. I know A of 1 is 189. R is 4/5. And to the 27 minus 1. Now, on your quiz and test, am I going to do this to you and make you do 4/5 to the 26th power? No. But on your homework, what do you have? So will I do it to you on your homework? Yes. And I fully expect you just to plug into Desmos, please. So 189 times 4/5 to the 26th power, I get 0.57. So A of 27 is 0.57. Yeah, I don't think this gives me a fraction. Let's see. No, there is no fraction option. So yeah. If you can turn it into a fraction, I would prefer it, but they won't always. Okay. All right. Just as arithmetic sequences are linear functions with restricted domains, geometric sequences are also functions. A geometric sequence can be modeled by an exponential function. Please write that, or box that, please. In which the domain is restricted to natural numbers. Remember, natural numbers are whole numbers greater than 0. Now, this next example, honestly, in my opinion, is not an example of a sequence. So I'm going to star this because you're not going to use the formulas I just told you. You're going to use the formulas we learned with exponential functions. Damien purchased a late model car for $15,000. At the end of each year, the value of the car depreciates by 11%. What does that mean? It's decreasing by 11%. What was the formula we learned to figure this out? Okay, so PERT was compounding continuously, but we learned it when we learned PERT. So it's going to be A of, not 1, A of 0 times 1 minus your rate to the n. You know how in our equation we have A of 1 and we had n minus 1? That goes together. If this was A of 4, we would have n minus 4 up top. Just letting you know. All right, so how do I write this explicit formula? A of n equals, what's our A of 0? What's our starting value? 15,000. 1 minus, what's our rate? 11. So how do I write that? 0.11 to the n. And how can I reduce this? What's 1 minus 0.11? So what's going to be the value of Damien's car at the end of the 7th year? What do I do? Change n to 7. So A of 7 equals 15,000 times 0.89 to the 7th. And if I put that in the calculator, his car is valued at $6,634.70. And don't forget to label it, and you put your units, your dollar sign out front. Do I have any questions about that? Will you be given a question like this on your test? Probably not, because I'm not giving you Desmos, so. Okay, does that make sense? If I did, I would be asking you like the third year, so you could just do it 3 times. Does that make sense? Okay. All right, last thing for sequences, and then we're going to move on to series. Similar to arithmetic sequences, if 2 non-consecutive terms of a geometric sequence are known, the term between them can be calculated. What do we call those terms between? Geometric means. Whenever you hear me say geometric means, what does that mean? The term. You're going to have some blanks. So right here, this sequence, write a sequence that has 2 geometric means between 480. That means 2 blanks between 480 and negative 7.5. Hey y'all, do you see how I wrote 480 first? That needs to come first in your sequence. On the quiz, some of y'all flipped it around. All right. For arithmetic, what did you do? Didn't we subtract them? Okay, we're not doing that for geometric. For geometric, we are going to use our explicit formula. Everybody write down the explicit formula, please. All right, what do I know? A of 1. Do y'all agree with this? It's A of 1. What else do I know? What's n? No, how many terms are there? Do y'all agree this is A of 4? So do we agree n is 4? So I'm going to say A of 4 equals 480 r to the 4 minus 1. What is A of 4? Negative 7.5 equals 480 r to the 3rd. How do I figure out r? Before I cube root, I'm going to divide by 480. And again in Desmos, when you divide these, you're going to divide negative 7.5 divided by 480. Look up. You get this ugliness. But watch. Hit the fraction. Doesn't that like make a lot more sense? So negative 1 over 64 equals r cubed. Now what am I going to do? What is the cube root of negative 1 over 64? If you don't know, cube rooted in Desmos. Do y'all know how to cube root? The shortcut? CBRT. And then you would just do negative 1 over 64. And it gives you that. All right, that's my R, but is that my answer? What do I got to do now? Multiply these by negative 1 over. So what is 480 times negative 1 over 4? It is negative 120. And then what is negative 120 multiplied by negative 1 over 4? And then guys, oh my gosh. Hey y'all, can you do it again just to check that you get negative 7.5? Because if you don't get negative 7.5, that's a sure way to say, oh, you did something wrong. Does that make sense? It's just a safe check. If you got it, you know you did it right. Are we okay over there? What are your answers? These are your answers. Not the R, just your blanks. Okay. Can everybody lift their hands in the air? Just like stretch your hands. Stretch them. Get some stretching. Twist your back. Pop your back. Get some blood flowing in your brain. Because right now y'all are a little dead. Poke your neighbor in the face. Just kidding. I'm just kidding. I'm just kidding. Hello. How we doing? All right. I will send him in just a little bit. Okay. All right. We ready to talk? I got less than 10 minutes. We ready? Okay. Focus. Look back up at the board. Less than 10 minutes. What is the difference between a sequence and a series? This is the third time we're doing series. Do we know? Series is adding all the numbers. A sequence is just the numbers with a comma listed. She's so nosy. Okay, is it always this class? Was it this class last time? She's so nosy. All right. It's because I'm saying series and she thinks I'm talking to her. Sequence, listing them out. Series, adding them together. Okay? I'm going to give you these formulas. If you have a finite geometric series, the formula is S of n equals, let me make sure I'm doing it right because I'm about to say it from memory and watch it be wrong. Oh, I was right. A of 1 times 1 minus r to the n times 1 minus r, or divided by 1 minus r. This is what you're going to use if you know n. If you know n, r, and a of 1. If you don't know what n is, a of 1. Oh, I'm sorry, I did that wrong. Oh, I did that wrong. Got ahead of myself. Ooh, this is going to look ugly. My bad. It looks ugly. Is a of 1 minus a of n times r over 1 minus r. This is if you know a of n. We are just going to literally be plugging into these formulas. Today and tomorrow, today I'm just going to plug them in. We're not going to focus on memorizing them. Tomorrow, as you do the homework, you're going to want to start focusing on memorizing them. For this one, a of 1 out front, both of them are 1 minus r, just the top one has an n exponent. For this one's still 1 minus r on the bottom. I don't have a good way to memorize that top. We'll think about that, okay? All right, so how do I find the sum of the first 6 terms of the geometric series 8 plus 14 plus 24.5 plus dot, 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 dot? What do I know? What do I know? N. What's n equal? Why is it 6? Literally tells me that. All right, thank you. Somebody in my front row. What else do I know? What's a of 1? A of 1 is 8. Cool. Perfect. Last thing, what do I need to know? R. How do I find R? Your second term over your first term. Y'all, what is 14 over 8 reduced to? I have n, a of 1, and r. What am I going to use? The first equation. S of n equals a of 1, 1 minus r to the n, 1 minus r. And you're literally going to plug in. What's my n? Plug in a of 1. 1 minus 7 over 4 to the 6. 1 minus 7 over 4. Am I going to give you something like this on a quiz to 7 over 4 to the 6th power in? No. Just homework. Okay. If I gave you something like this on the quiz, that r should be a whole number. It would be like 2 to the 6th. You can do 2 to the 6th in the baby calculator. All right. So let's type this into Desmos. It's going to be 8. And then the fraction is 1 minus 7 over 4 to the 6th power. And then 1 minus 7 over 4. What do we get? So S of 6 is 295.71. And that's it. What's going to be the most difficult part about this? I wish rounding was the most difficult part. Do you memorize the formulas? That's it. That's going to be the hardest part about this. Y'all are going to be very good at finding these things. Do you memorize the formula? B. I gave you all these things. A of 1, A of n, R. Which equation are you going to use? The second one. Oh. Do I have any questions here? Does this make sense? We're just plugging into the formula. Yes.
Would they always give us R or some way to find R?
Correct. Well, if they don't, you would do this right here. Does that make sense? Like, that's the only time you would do this. Okay. I want to make a comment real quick. Do you see how up here we labeled this S of 6? Do you see how right here I have it labeled S of n? I am okay. I did not give you n, did I? I am okay with this answer. This is a correct answer. Full credit. However, could I find n? I can't. And so what I'm about to show you would be extra credit if you wanted it. So, you can write this down. You don't have to. This is just extra credit on your quiz if you want to go an extra step. How would I find out n for this problem? I'm going to plug it into the original equation. Remember my original explicit formula is a of n equals a of 1 r to the n minus 1. What's a of n? No, that's S of n. What's a of n? 768. What's a of 1? What's r? N minus 1. How do I solve for n? I cannot multiply these because this has an exponent. I am going to divide by 3. What is 768 divided by 3? What am I going to do next? Close. So a lot of people have said natural log. Actually, every class period has said natural log. Natural log would work, but don't I want to get rid of it? So instead of natural log, I'm going to log base 2 this on both sides. Does that make sense? Does anybody know what 256 is if it has a base of 2? It is 2 to the 8th. Now, what happens here? They cross out, and I'm left with A equals. We have a dilemma here. What's our dilemma here? It's negative. Can you have the log of a negative number? No. So, on a technicality, we would actually take the absolute value of this so that it would work. I'm going to show you why in just a second. But this is going to end up canceling out and giving us what? N minus 1. So what is N equal? No, 9. Does that make sense? So this is technically S of 9 equals 513. What I just did is extra credit. If you have extra time on the quiz, go back and do this. Don't do this right away. It's like 3 points, extra credit. You're like, yeah, I don't need it. You get full credit if you left that as in. Do you agree if I plug 9 back in right here? What's 9 minus 1? And do you agree if you take something to the 8th power and it's negative, it'll turn into positive? That's why this ends up working. If it didn't, then it would be undefined. So there are some situations it doesn't work. Okay? All right, last one. We're almost done. Questions? Again, that's extra credit, extra points. Don't worry about it if you don't want to do it. Last one. What do I know? What's N equal? Well, that's what it starts off. How many blanks am I going to end up having, though? N is 7. What else do I know? A of 1 is 3. That is my A of 1. What else do I know? What is that? That's my R. Do I have everything I need? How do I find the sigma of this? What do I do? What do I do? The first formula. We know N. I'm going to use my first formula. This is a good example of something I might give you to do in your baby calculator. Could you do 5 to the 7th power in a baby calculator? Yeah, you can. I mean, it's 1, 2, 3, 4, 5, 6, 7. Is it a big number? Sure. But can you do it in your baby calculator? Also sure. 7, 8, 1, 2, 5. I got 58,593. What questions do I have? You are just plugging into these formulas. It's a 5. Okay. If you see sigma, if you see nth partial sum, if you see something about sum, you are using one of these formulas. All right, you have about 13 minutes. Y'all get started on your homework, please. You could probably do 4, 8, 12, and 16 right now.